Dear students, today we will discuss about the operators in Arduino. These operators which we are going to discuss are actually a part of the C language, but they are used while the programming the microcontroller, the Arduino microcontroller. So here is the list of Arduino operators. As you know that an operator is a symbol that tells the compiler to perform specific mathematical or logical operations. So the operator types are like we have the arithmetic operators for like addition, multiplication, subtraction. Similarly, we have the comparison operators for making a comparison between two different variables. Now then we have the Boolean operators, then we have the bitwise operator, then we have the compound operators. In this video we will discuss all these operators, their symbols, their description, and how they are used, and in an example. The first operator we are going to discuss is the arithmetic operators. So first of all, let's assume that there are two variables, like the variable with the name a that holds a value 10 and another variable b that holds a value 20. So we will apply all those operators on these two variables. So let's say the first operator we have in the category of arithmetic operator is the assignment operator, and its symbol is equal to sign. And what this variable operator do is that whatever the value on the right side of this operator the variable have will be transferred to the value to the variable on the left side. Like if we do a is equal to b, then the value of b will be shifted to the value of a. So in this case a will hold the value of 20. As you know that we have given a variable a value 10, but after doing a is equal to b, the value of b will be transferred to the value of to the variable a. The next operator we have the addition operator, and its sign is plus sign. What it will do, it will add both the operands, like it will do a plus b and will generate a result, like the sum will be 30, as 10 plus 20 is equal to 30. The next operator is the subtraction operator, and it has the symbol of like a dash or the minus sign. And what it will do, it will subtract the second operand from the first one. Like if we do a minus b, then it will generate a result of minus 10. The next operator we have is the multiplication operator. It is shown by a asterisk sign. It will multiply both the operands, and if we do a multiplied by b, the result will be 200. The next operator we have is the division operator by a forward slash. It has a symbol like a forward slash, and it will divide numerator by the denominator. Like if we do b divided by a, this will generate a result 2, as 20 divided by 10 is equal to 2. The next operator we have the modulo operator, and that is shown by a percentage sign. Modulo operator actually calculates the remainder after an integer division. Like if we do b modulo of a, as you know that if we divide 20 by 10, the remainder is 0, so it will give a result of 0. So these are the arithmetic operators that are used in the programming of Arduino microcontroller. The next operator type we have the comparison operator. Let's again assume that a holds 10 and b holds 20. Then the first comparison operator is equal to, that is represented by 2 equal to sign. What it actually do is it if the value of two operand is equal or not, if yes, then the conditions become true. Means that if a holds 10, b holds 10, then it will be true. As currently in our example, a has the value of 10, b has the value of 20, it will be written as a is equal to b, and the result will not be true. It will generate it will say that a is equal to b is not true. The next comparison operator we have is not equal to, that is represented by an exclamation sign followed by an equal to sign. It checks if the values of two operand is equal or not. If not equal, then conditions become true. For becoming the not equal to be true, then both the operands should not be equal. So it is represented like this: a not equal to b. As you know that in our current example, a is not equal to b, so the condition will become true. It will generate a true result. Then we have the comparison operator less than. It is represented by a less than symbol, and it will check if the left operand is less than the value of the right operand. If yes, the conditions become true. Like if we say a is less than b, it will be true because a holds value of 10 and b holds value of 20. The next we have the greater than comparison operator. It is represented by a greater than symbol. So it checks if the value of left operand is greater than the value on the right operand. If yes, the conditions become true. So example, in the example you can see we write a greater than b. As you know that a is 10, b is 20, so a is less than 20, so this condition will become false. So this comparison operator will generate a result that a greater than b is not true. Then we have the less than or equal to, that is represented by less than or equal to sign. It checks if the value of left operand is less than or equal to the value of right operand. If yes, the conditions become true. As you know that a is less than equal to b, as a holds 10 and b holds 20. In this comparison operator, there are two conditions. Like it also checks that a should be less than b. It also checks that a is equal to b. Either of the condition, less than or equal to, from both of the conditions, if one is true, this comparison operator will generate the result true. So as you know that a is less than b, then it will generate a result true. A is less than b is true. Then we have the greater than equal to. It's greater than or equal to. It checks if the value of left operand is greater than or equal to the value of right operand. If yes, the conditions become true. Just like the less than or equal to operator, the greater than equal to holds two conditions. Like it also checks that the value should be greater than, and it also checks it should be equal. So if any other condition, the greater than or equal to, is true, the result will be true. Like if a is greater than equal to b, as you know that a is not greater than b and a is also not equal to b, so it will generate a result false, or a greater than equal to b is not true. So these are the comparison operators that we have studied. These are all the operators are very important for understanding the programming language. The next operator we have the Boolean operator. So let's assume that a holds 10 and b variable holds 20. The first operator we will study is the AND operator, that is represented by two AND signs. What it will do, it's called logical AND. As you the name suggests of the operator is the Boolean operator, so this will operate on the 0 1 value. Like called AND operator, called logical AND operator, if both operands are non-zero, then the conditions become true. Like if a and b, for this condition to become true, the a should be non-zero, b should be non-zero, then the result will be true. If from both a and b any one is 0 or both are 0, then it will generate a false result. As in our condition, both are non-zero number, so a and b is true. The next operator we have is the OR operator. It is represented by these two lines. What it will do, that it's called logical OR operator. If any of two operand is non-zero, then the conditions become true. Like a or b. So a or b is true, as it says that if a or b both are 1, both are non-zero, or any one of the A and B is non-zero, then it will generate a result of true. The next operator we have is the NOT operator. It's called logical NOT operator. It's used to reverse the logical state of its operand. If a condition is true, then logical NOT operator will make it false. Like if you write NOT of A and B, it will generate a result false, because in the previous on the point number 1 where we have studied the operator name under operator name AND, we have studied that A and B is true. If we do NOT of it, it will invert the result and it will generate a false. So these are the Boolean operators AND, OR and NOT. The next we have the bitwise operator. As the name suggests, that it will be operate on the single bit of the operands, one on bits of the operand. Like assume that A holds a 60. I have also written the binary values, and the B holds a value 30. You can see that I have written binary values. Then if we have a bitwise AND operator that is represented by a single AND sign, what it will do, that the binary AND operator copies a bit to the result if it exists in both operands. The AND operator will do its represented A and B. Like over here on the top, you can see that on the very first bit on the LSB we have 0 0, then we have a result of 0, then we have 0 1, we will again have a result of 0 1, because 1 will only be generated if we have both the ones over here. Like this is 1, this is 1 at the third place, so result will be 1 1 1 at the fourth place, result will be 1. At the fifth place we have 1 1, the result will be 1. Again 1 and 0, the result will be 0. So the binary AND operator actually sees that if there is a 1 in both the operands, then it will generate 1. So the next operand we have is the OR operand, that is represented by this single line. Binary operator copies a bit if it exists in either operand. If let's say it's represented by like this ARB, so what will happen, that if there is a bit 1 on any of the operand, like over here we have 0 0, both are 0, so it will result 0. If there is 0 and 1, so any of the operand have 1, it will result into 1, like 0 1, it will give 1 result. Then 1 1 1 1 will also generate a 1 result. So there are, in this case we have 5 ones, like 1, a total of 5 ones in the output. So we have 3 to 5 ones over here. So the OR operator actually sees that if both the operands have 1 1, or one of the operand have 1 and the other have 0, it will generate the output of 1. So the next operator we have over here is XOR, that is represented by this sign. Then we have the functionality is that it checks if in both the operands either should have 1, the other operand should have 0 at the same bit position. So if one is 0, the other is 1, then it will generate an output of 1. So the XOR operator copies the bit if it is set in one operand but not the both. So it is written that A XOR B. So over here you can see that we have only two positions that have a difference in the value, like that have 1 over here, then at 0 it will generate a 1. Similarly we have this position 1 and 0, this will generate a 1, while all the other conditions like 0 0 will generate 0, 1 1 will generate 0, and all three these three in which both operands have 1 1, this will generate 0, and 0 0 will automatically generate 0. So the XOR operator will check that one operand should have 1, the other operand should have 0, then it will generate an output of 1. The next we have NOT bitwise operator, that is represented by this sign. Actually it will turned 1 into 0 and 0 into 1. It has an effect of actually flipping the bits. So it's represented by not of a. As you can see that we have 60 over here. If we do not, then we will have 1 1 0 0 0 0 1 1. The next operator we have is the shift left operator, that is represented by two less than signs. It actually shifts the operand by the number of bits that is specified on the right side of this operand. Like let's say if I say that a shift left by 2, then it will shift the bits 2 bits on the left side. Like over here you can see that a shift left by 2, we have a over here 60. These two zeros will be discarded and these 4 will be shifted by the on the left side, and we will have the result like 1 1 1 and 0 0 zeros after a shift by 2 shift left by 2. So this will result a has a value of 60. If we do shift left, we will get a value of 240. Then we have the shift right, that is represented by two greater than signs, that actually shifts the operand on the left by the number of bits specified on the right. So if we say that if I want to shift a towards the right by 2, then what will happen that these 2 bits will come over here, these 2 bits will come on this position, and we will have these zeros at these 2 1 positions, and 2 zeros will be added over here. So this will result in this as a has a value of 60. If we do shift right operator, we will get a value of 15. Then we have the compound operators like assume variable a holds 10 and a variable b holds 20. Then the first operator, the compound operator, is the increment operator. It's actually represented by two plus signs. So increment operator increases the integer by a value of 1. Like if I do a plus plus, this means that I am going to increase the value of a by 1. So a will give 11 by a plus plus will give a value of 11. Similarly, we have the decrement operator, that is represented by two minus signs. So this will reduce the value of the integer by a value of 1. So a minus minus, this will generate a value, this will give a result of 9. Then we have the compound addition, like plus equal to, this actually add, these are actually doing two things. It will add and it is also assign. Like if I say b plus is equal to a, it's same like if I'm doing b is equal to b plus a. It will add b and a, and then the result will be assigned to the b operand. So in this case, if I do b plus a, that will generate 30, and that will be assigned to value to the variable b. Similarly, we have compound subtraction, that is represented by minus and equal to a. It will do the same two things. It will subtract and it will assign. How it will do that? That we have b, my compound operator of minus is equal to a. It will do that. It will do first of all b minus a, then the result will be assigned to b variable. The next thing we have the operator, we have the compound multiplication, that is represented by asterisk and equal to. It will do the same thing, that two things. It will do multiply and then assign. Like if you write b asterisk a is equal to a, then what it will do, that it will multiply b with a, then the result will be assigned to b. The next operator, we have the compound division. This is represented by a division sign and then equal to a. It will do the same thing. B divided by a. It will first divide b by a, then result will be stored into b. So over here, these operators, like you have seen compound addition, compound subtraction, multiplication, compound division. The difference between others arithmetic operators and compound operator is that in this we write like this, like shown in the example, and the results are assigned to the operand that is actually taking part in the addition, subtraction, multiplication and division. The next compound operator we have is the compound modulo. It's same as we have studied. It will find out the remainder and will store in the first variable. Like if you do b compound modulo equal to a, that is same as b modulus of a. It will divide b by a. Then the remainder will be stored in the b variable. Then we have the compound bitwise OR, that is represented by like this. Bitwise inclusive OR and assignment operator, it performs two functions. It will do bitwise OR and it will assign those value on the operator at the left. Like if I have a compound bitwise OR b, then it will be same as a or 2. Like if I do a compound bitwise with 2 is same as a or 2, and the result will be assigned to a. Next we have the compound bitwise AND. It is represented by this sign. It will do the same thing, bitwise and then assignment operator. It will first perform bitwise AND, then the results will be assigned to the operand on the left side. Like it's represented like a and b is the same as doing a and with 2 and then assigning the result to the a. So these are the list of compound operators that we have studied. Compound operators are actually makes a little life easier by just writing that two operands are taking part in the calculation and the results are stored in the left side operand. So these are also useful. We will study these while moving forward in this course. Just a quick summary of what we have studied in this video, that we have studied about the arithmetic operators like the addition, multiplication, subtraction, division. Then we have studied about the comparison operator. Then we have studied about the Boolean operators. Then we have studied about the bitwise operators. Then at the end we have studied about the compound operator. So these are the 5 different categories of the operator that we will be using in the coming videos.